What's up, scientists?
Who's ready to learn?
Yeah. Today, me and Nick did this experiment where we tested the different densities of liquids and how it affect the terminal velocity of a ball falling through them. So we used 5 different liquids. We had water, salt water, canola oil, detergent, and hand sanitizer. And we used this glass vase here filled with each of the different liquids. We had the ball, we dropped it from the rim, and measured the terminal velocity at the bottom. So here's a picture of our data table. You can see that the liquid with a density of 0.855 grams per milliliter had a terminal velocity of 0.0383 meters per second. And the liquid, I think, was salt water, which had a density of 1.056 grams per milliliter, had a terminal velocity of 0.0128 meters per second. And here's a graph of all of our data points. As you can see, there is a negative linear trend.
The claim is that as density increases, the terminal velocity will decrease. We have 2 data points to prove that. One data point where the density is lower at 0.932 grams per milliliter, and the velocity is higher, which is at 0.21 meters per second. And then another time, we increase the density to 1.0559, and the velocity decreased to 0.107. So this proves that if you decrease the density, you increase the terminal velocity. Okay, our second evidence is our best fit line when we made a graph of density versus terminal velocity. Our best fit line was negative. So if it has a negative slope, that's just proving that as the density decreases on the x-axis, increases on the x-axis, the terminal velocity decreases on the y-axis. And lastly, our slope found the actual, how it decreases. So our slope was negative 0.124, which just shows that for every 1 gram per milliliter, the velocity of the ball decreases 0.124 meters per second. Okay, so for reflection, there's basically 4 errors: transparency, the stopwatch, the ball itself, and the current of water. So let's start with transparency. As you probably saw, some of the time it was kind of hard to see through the water, and we used a light and everything, and it was just basically very hard to record data for that. It probably made the data relatively inaccurate because it was just, you could barely see the shadow in the recording, but it was still you could take stuff. It was really hard to do it. Okay, another source was the use of slow motion. So instead of having it in centimeters per second as we would have liked to, it was in whatever the iPhone uses for seconds. So it was really in centimeters per 0.006944 seconds, which is it's a unit that you can't really comprehend. And then our third source was the lack of density in the ball. So basically, you remember when we had our salt water, it floated. And that really sucked because we couldn't do any liquid denser than salt water. So our liquids had to stay relatively the same density because we couldn't find anything that was really dense for the ball to sink through, because it just couldn't. And our last source of error was the current. So a lot of the times when we dropped the ball, it'd spin in a circle or it'd hit the side, and we noticed that kind of messed up the data. So in the future, we'll just wait for the ball to settle down, or for the water to settle down, so then we can drop the ball in.
2.
Our balls don't dribble. That was perfect.